Howdy, folks.
I'll introduce myself real quick since you guys probably haven't met me yet. Karina Ung, marketer here at Wilderness Labs. Welcome to our Fireside chat here and Q&A with Bryan Costanich, CEO and co-founder. Now, if you guys have questions that you guys would like for us to answer, we'll try to get to them. So feel free to either add them on the Zoom Q&A or over Slack, and we'll have Bryan Kim feed them over to us. So we'll go ahead and get started, Bryan. So the first questions here. First of all, holy crap, though. Can you guys imagine that this is the end of like the very last session? This is awesome. It's been 3.5 years building Wilderness Labs. Like, what got you started?
That's a good question. Well, first of all, yeah, I can't believe this is over as well. I'm also surprised we pulled it off. So folks don't know this, but 3.5 weeks ago we decided we were going to have a dev conference, and so we did all this in 3.5 weeks. So really excited that we actually were able to do it, and I think it went pretty well. I think we had some really great content, and I know I had fun. So, and according to Twitter, it sounds like other people had fun too. Anyway, back to your question. So what got me started? What inspired me? So for a long time, by the way, for those of you that are out there, like they're not 6 feet apart. So we're actually neighbors, and so we've been quarantined together for months now. So what got me started building Wilderness Labs, or the idea? And I have been involved in .Net since day one. In 1999, I think it was, Scott Guthrie gave me an email, or dropped me an email and said, "Hey, we've got something new going on, and we'd like for you and some other folks from around the world flew over to Seattle, and we did a software design review of .NET, and it was like ASP Plus and some other, it wasn't even called .NET then. And I saw it and I was like, this is a game changer. This is an absolute game changer. And .NET was finally released in like 2001-ish. And it was, I actually worked on the .NET team early on, and then it's funny, I worked on the .NET team, and back then Mono was like the enemy, because it was back then, it was like, oh my God, everything's closed source and proprietary. Microsoft was afraid of open source and stuff. And then I actually went on work on the Mono team at Xamarin and stuff, or work on Mono as part of Xamarin. And the whole time in doing .NET, I've always really been in love with it. .NET has, like anything, it's got its challenges in it and whatnot. But honestly, if you look at development frameworks in the world, there is still no better framework out there. Like overall, .NET is the absolute best, hands down framework in the world. And that remains true after 20 years of it being up. And so, yeah, first of all, I love .NET. And second of all, I've always wanted to be able to do .NET, take my .NET skills and put them other places. And that was a big driver of Xamarin, was that we wanted to take .NET and we wanted to enable .NET developers to build mobile apps, because who the heck wants to do Objective-C, right? I mean, Swift's a little bit better, but Objective-C was just objectively terrible. So we brought .NET to that, but even before Xamarin, I've always really liked building things. You can see this is the lab, and half of it's wood shop, and then half of it is the electronics shop, and there's a curtain that comes in between to protect the electronics from the dust. But I've always really liked building things. And early on when the .NET Micro framework came out, it was so promising, because it was like this first foray into using .NET to build physical things. We had the .NET Micro framework ran on early microcontrollers, early modern microcontrollers, and it was just really eye-opening, And then NetDuino came out, and Secret Labs had created that. It was just like, wow, this is really, really incredible. But .NET kept moving forward, and the .NET Micro framework stopped development back in the early aughts. And so .NET Micro framework basically stayed at like .NET 1.0, which is at this point, after 20 years of .NET, we are so far beyond that. We're so far beyond it that we've got like multiple naming conventions, that we're like multiple naming conventions past what .NET versions mean and whatnot. And so when Xamarin was acquired by Microsoft, I was thinking about, the next thing that I wanted to do. And I have, like I said, for years, I've really wanted to be able to do connected things and build them with .NET. And so we sat down and as I said in the keynote, I really asked myself this question. I was like, okay, so what would it take to make connected hardware development, embedded development really as easy as any other modern development? And it meant, getting mono running and on microcontrollers. And that was like our first challenge was, okay, let's get mono up and running and try to figure out, when then we can go from there. And then the things that came after that, the full stack of IoT came after that. But it was always my love of like building physical things and .NET. And I was evidently there a lot of other people have the same loves, because we were able to recruit a bunch of folks that have been working with us for a while now and building that and doing exactly that. So that's, that was kind of how it started out.
So when you started, with all of this, did you know that you were even going to get mono onto a microcontroller? I mean, has that been done before?
When you first started? No, it never has. And it was, we wanted to. That was certainly the goal. And I remember it was like almost 4 years ago now, and I sat down with Jeff Norton, who was the guy who originally did all of the early Xamarin stuff. He was the guy that did Mono Mac and Mono Touch and Mono Droid, the original what became Xamarin. And I started talking to him, and I said, well, I kind of like let him into it, and I was like, well, what would it take to get mono up on running on a microcontroller? And I remember at the time, he said, about 6 months. And that was almost 4 years ago, and we're just now sort of approaching that.
Yeah, it's been 3.5 years now, right?
V10 timeframe. So yeah, we didn't, we thought we would. I certainly started the company with the idea that it would happen. Although I have to say there were points in which we wondered. There were points that we hit some bottlenecks, and we stared at things. I remember Jeff and Bryan Kim, both co-founders of Wilderness Labs. We were up and we were hacking at the dining room table and stuff. And I was watching Jeff just like blast through hardware problems and stuff. And we hit some things that were like really, really hard to get past. The thing about microcontrollers is that they are not anything like anything else that you would develop on, traditionally. The way that memory is handled, the way that like all the low level stuff is so different. And we thought, okay, well, Mono runs on iOS and on Android, so it runs on ARM32 chips, right? It runs on this instruction set, so that should be fine. That shouldn't be hard at all. But we dove in there and we found out, oh my God, this is like absolutely way different than getting this to work on mobile. And I have to say, in my almost 30 years of spending time in this industry, this Wilderness Labs of building Meadow, it's been the absolute hardest challenge I've ever tackled. Like actually building this platform and getting .NET to run on microcontrollers. There's nothing that I've done that's been harder than that. So it's been absolutely a labor of love. But there were some moments there where we wondered, is this going to happen? Are we going to be able to get to
labor
this?
of love? That's a good way to put it, and how far we've come.
Yeah, that's right. That's right.
So speaking of Wilderness Labs, how did you come up with that name?
That's a really good question. So it's a kind of a dark story with a happy ending. So when we got acquired by Microsoft, I was kind of thinking about the next thing, and I came up with this idea of this company, or this rather the idea of the platform of Meadow before it was named or anything. And I was coming up with, like thinking about names and stuff. And at the time, my wife had cancer. My wife came down with very aggressive breast cancer, and it was a tough battle. And the thing that kept me sane is that so we actually moved to effectively the wilderness. If I opened up the doors here, there's a river right there, and there's trees right here. And every single day, I would go for a walk in the wilderness, which is just out the door, and it kept me sane. It kept me sane while we were battling through this cancer, and it just seemed appropriate. It seemed appropriate that it was literally a wilderness lab. The lab is here in the wilderness, and then there was also the metaphor of me walking in the wilderness, every day for miles, just trying to clear my head and trying to like come back to the earth and like, just walking in the wilderness. And that's where a lot of the thoughts, that's where a lot of like the early designs and drive came from. So it just seemed appropriate. Wilderness Labs.
It's a beautiful place too. I can attest to that because I'm right next door.
Yeah, that's right. On the Salmon River in beautiful Brightwood, Oregon. This is actually where we create, we assemble the hack kits as well.
From here.
Yep. In fact, it started in her garage. We were assembling hack kits over there, and now we have a storage unit just down the road that we assemble them at.
Say real startup life for sure. So I actually have a question from, let's see here, from one of our audiences, Eric Newbert here. Whatever happened to Windows 10 IoT Core? It seems like your product supersedes that. Can you talk about that one?
Well, it's a good question. Windows IoT Core still exists. It's out there. It's a thing. But for us, it never really answered what embedded needed to be. First of all, it took a very different approach than we took. It's really a Windows-centric approach, and the way that a lot of the APIs were thought of and stuff I don't think that they, I think that the approach that we took was just way better for embedded. And so it's still out there. It doesn't run on any microcontrollers that I am aware of. It runs in app processors, so it runs on like Raspberry Pi. It doesn't even run on the Azure Sphere, which is also an app processor, but it doesn't have enough memory to run it. So it does exist, but I think that superseding is. I think in spirit it probably does. Meadow probably does supersede or replace IoT Core. Meadow's really built for embedded, and IoT Core is really built for small single board computers. Yeah.
Yep. So, you've already talked a lot about challenges with Dotnet. It's a lot to get on this Meadow hardware, this microcontroller. What would you say was probably one of your biggest challenge getting this on a microcontroller?
Man, biggest challenge. I would have to say it's memory. It's the way that memory works in microcontrollers is very different than it works in other hardware platforms. And so that was probably the biggest technical challenge, was probably around, just like getting memory to work right, and a lot of low level stuff there. And of course, network, which was, related. Our network architecture is really interesting because, hopefully you folks saw the Mark's demo, because there's two chips and we're communicating, and network has been a big challenge as well. But I want to say this, which is kind of related, and I mentioned this in the keynote, is that one of the biggest learnings that we've had in building Wilderness Labs is that the hardware itself hasn't actually been the hardest part of building this. It's like the entire industry of embedded development is an opportunity-rich place in the sense that like all of the software in this area is incredibly primitive and is just like locked in decades before. And so for us, I would say, working with all the existing software and building the software, that's really been the challenging part. And it's not, I like to think that we're doing the hard part, so that you don't, so that you folks don't have to, that for you, it's really like a plug and play experience. And, building the apps is like building a web app or a mobile app. So yeah, that's those are the kind of the challenge, I would say.
Yeah, no, that makes sense. I actually have another question from one of our attendees here. Do you have any roadmap to share for Meadow OS and Mono runtime from Meadow as an open source? And so what can what can developers do to contribute?
Yeah, that's a great question. So most of the stack is actually open source. The only thing the thing that is closed source is Meadow Core and our OS integrations and stuff. And I think that we'll keep that proprietary for a while. I think at some point it'll get opened up, but right now that's our core IP, and so we want to keep that sort of close to hand. However, with that said, Meadow Foundation is like the right place to get involved and help out. Also, the Visual Studio add-ins, both Visual Studio for Windows and Visual Studio for Mac. The video from Stuart earlier about the sign at source chip. So you saw his great Mono develop add-in, which is way better than our Visual Studio for Mac / Mono develop add-in. So that's actually a case in which someone in the community has stepped up and done a lot of work to make that add-in way, way better. And now there's a pull request out there that has some, there's some work to get it merged and stuff, but like that is a great place to contribute. Meadow Foundation, if there's a driver that you want that isn't in there, then absolutely, go take a look at the drivers are there. You can see how they're built. You can, in our doc site, we talk about, the patterns of eventing and iObservable and how to implement those. So Meadow Foundation is a fantastic place to get help contribute. And when we ship the Core 3.0 support, which will be coming down the pipe very shortly, I think the VS Code add-ins will be a place where we can, there'll be a lot of opportunity to help as well, because that is like a pile of work, and we don't know anything about VS Code add-ins anyway. So.
Awesome. Well, you guys heard that, so make sure you guys contribute if you can. Now, for folks who are a little bit hasn't had much experience with hardware development, what are some of the best ways they can get started if they have a web or mobile development background?
Oh, another great question. So I would say start with, go to developer.wildernesslabs.co and get a hack kit.
We have a brand new website, by the way. It's got a beautiful, beautiful interface.
That's right. Oh, that's our main website. Developer is our doc site.
Yep.
So go to our doc site, and there's getting started tutorials. Get a hack kit. So go to store.wildernesslabs.co and buy a hack kit. And I'm saying this not to like sell hack kits, because I want to sell hack kits because it helps us out and all that money goes back into our R&D, but because we spend a lot of time really designing those and building stuff around, like that is a very, very practical hack kit. That has sensors and motors and all kinds of things that we have drivers for and whatnot. And that is like a practical way to just start building. Think of it as Legos. And then go through the getting started stuff, get your environment up and running, and make sure that you can deploy and you can, build some basic apps, and then go to Hackster. There's a link to all our Hackster projects on the developer site. Go check those out and start building those and start to understand, what goes into those and stuff. And then, create a project for yourself or create projects. Just think of something that you can build that might make your life better, easier. For example, Bryan Kim, he's working on a sprinkler system, automated sprinkler system for his house. And that's like a great project to jump on. I've got the Beehive thing and some other projects, but you've got to, pick a project and break it into pieces and just start building on it. Go find the components that you need, start solving those different pieces, and, just start building, and we'll be there to help you. We will absolutely be there. If you're on the Slack, we are always answering questions. And if there's any documentation that's missing or whatever, let us know and we'll get it documented. If there's concepts that maybe are you don't understand or whatever, again, like reach out to us. We probably either have it documented or we want to document it. So, light a little fire under our butts, and we'll help you out as much as we can. And there's also, on the developer side, there's also a fantastic electronics tutorial for folks that have never done electronics before. So that's a great way to like kind of immerse yourself and start to understand. Think about this as it's a little bit like, you know, when you were learning Xamarin.iOS or Xamarin.Android, it's a new platform. So it's all .NET and whatnot. And so really you're learning the platform idiosyncrasies and specifics. And, you know, think of hardware as that. It's a skill that anyone can pick up. This is really not rocket science, it turns out. And especially not the hardware that we would be building in IoT solutions. It's really not all that hard. It turns out it's fairly easy. It's a lot of just like putting stuff together and you know, the occasional debugging because your ground's not wired up right or something.
Yeah, that's awesome. And so, you know, Meadow, working with Meadow and Dotnet is so powerful. What is it about Dotnet and Meadow that makes it so powerful to build IoT and connected things?
What is it that's so powerful about Meadow that makes it easy to build? You know, it's really, this is an interesting thing because Bryan, Kim, and I have been talking about this for years, and it's not any one thing. It's like the sum of the parts. It's the fact that we've tackled this, we've tackled IoT from top to bottom as a whole, from a holistic perspective of how do you make hardware easy for folks. And so, you know, we've solved the hard parts of hardware. We've spent a lot of time on the APIs and making them really, really easy to use. And we've really been trying to demystify and pull a lot of the difficult, you know, a lot of the difficulties and a lot of the esotericness out of hardware and making it something that is just super approachable. And the fact that you have .NET to build these things, I mean, if you're writing, and I have to tell you, because we do this on a daily, you know, our stuff, a lot of the stuff is written in embedded C, and it's no fun, you know, like it's very esoteric. It's a very specialized skill set. And so just moving from that to .NET and having like modern tooling, that I think is probably the biggest thing. But overall, it's the fact that we took this holistic view and we said, look, we need an easy OS. We need beautiful curated APIs around the IO, around hardware access. We need to rethink about everything. In fact, I just read something here on our little chat, and it says, and I'm really, this is very flattering. Oh man, I think it just went away. It said, how did you come up? Oh, here. How did you come up with the APIs? These are some of the best I've used. And to that point, every single time that we were building an API, every single thing that we were thinking about, like from digital inputs to I2C, I forced the team to ask themselves, we know how this has been done in the past. You know, we've seen these APIs before. We see how they're done over here. We see how they're done over here. Is that the right way? Are these actually the right ways to do it? And so I think of Meadow OS as iOS for embedded. So we really wanted to rethink everything. And we found that there's just a lot of legacy cruft in existing platforms around APIs and around the way that people thought of how to do things, you know, around how things should be done, just because they've been done that way for, you know, 50 years. And oftentimes they've been done that way because of some limitation that existed in the 70s. You know, it was some limitation and some chip back there. And so now everyone does it this way. And we're looking at those things, and we really wanted to be critical about that and say, is that really the right way to do it? And in many cases, it wasn't, you know, so we wanted to rethink the whole thing from top to bottom. And then, like I said, the other thing that we knew that folks needed was we wanted this to be plug and play. We didn't want you to go grab sensors and modules and plug them in, and then and this is how it is with other platforms. You have to go and either write a driver yourself, or you go and find a driver that exists out there. Maybe you pull it off of Adafruit or SparkFun, and it's like, maybe the driver doesn't work the way that you need it to. Maybe there's some bugs, and certainly this driver doesn't look like the driver over here. You know, here's an atmospheric sensor that does temperature and humidity, and this one does temperature, humidity, and barometric pressure. But the APIs are completely different, you know, and like we wanted to nip that in the bud right away. So we did a lot of work to make sure that there was like a cohesive and what's the word when everything's the same? Consistent. We wanted to make consistent APIs, you know. And even with Meadow Foundation, when in beta 3.11, you'll see that we redid a bunch of APIs for a big chunk of the drivers on there because they didn't match some of the other ones, right? So that's the kind of thing that we really have been spending time on, and it's absolutely a platform that's like made from love, you know.
Yeah,
like
lots of work too, but
yeah,
making it so it's such a plug and play. You mentioned Adafruit. How connected is Wilderness Labs to Adafruit?
Oh, we're not. Well, I mean, we love Adafruit. We love SparkFun. And, you know, shout out to those guys. Those are both incredible companies run by incredible people. Lemore Freed and, I'm forgetting his name. The other guy there. Fantastic folks, hackers from like back in the day. It's funny. I was reading a 2600 magazine the other day, and they had article. There was an article that I was reading, and it was written by, I'm forgetting his name. I'm terrible at names. And also Nate Seidel over at SparkFun. You know, we for years I've been reading his stuff and buying his products, and they're just great. You know, so they're just in our ecosystem, but we're not connected in any way.
Sweet. Now for folks who are again learning with hardware development, we have a question from one of the attendees. What would be easier, learning C# or us implementing Visual Basic?
Sorry, I think Visual Basic is fine, but I don't know. I think it's time to just go learn C#. If you know Visual Basic, look, I don't want to poo-poo Visual Basic. It is actually, it's honestly, it's a good language. It really is. It's just, I always, Visual Basic just feels so antiquated to me. I don't know. I mean, maybe because it's the legacy or whatever, but I think actually doing Visual Basic and running it on the Meadow is probably like an easy thing to do. I don't think any of us have actually tested any of the other .NET languages on Meadow because we haven't had the time, but they should run. They should just run. There maybe needs to be some tweaks in the add-ins to make them right. And we don't have templates for Visual Basic. I'd like to see F#. That's the one that I want to see on the Meadow, because like F# is just, it's such a cool and interesting language, and it's so perfect for certain types of problems, especially on hardware. So I'd love to see that one, but yeah, I don't think we have any like plans immediately to get VB running on there. But if you want to, you could probably do it yourself. Truth be told.
Awesome. I have
also Visual Basic is the language that just won't die. Like Microsoft just tried to kill it over and over and over, and it just like they've decided, they've given up, and they're like, okay, this won't die. It's gonna be around forever.
So there's been many accounts of IoT devices getting hacked. Where is the security priority on our list with Wilderness Labs when it comes to Meadow being secure? I think that's super crucial, especially given today's situation. Just what are your thoughts around that in terms of security?
Yeah. So security for us is priority one. And we designed and thought about Meadow, thought about security in Meadow from ground up. So later this year, we're actually going to, or early next year, we're actually going to ship the security stack. It'll come in phases. Some of it'll come earlier, but yeah. So definitely go check out our website because we talk about this. So Meadow is really designed with defense grade security in mind. And when I say that, I mean truly, like we have thought about security from the ground up, from the hardware up. So the first thing that we'll be shipping is the ability to encrypt your firmware and only run firmware that matches your keys on the microcontroller that are burned in one-time programming, read-only memory, all the way up the stack. So we're in a partnership with TFA Labs. So folks saw the demo earlier with Stuart and the signed at Meadow, the signed at source. So we're actually creating a Meadow signed at source module, which integrates both Meadow and their crypto libraries and the blockchain and Merkle tree validation and stuff. So for like true defense grade security, we actually have some contracts in the energy space, and this is something that we've been thinking a lot about. So if you want real heavy duty security, that module, that Meadow TFA, Meadow signed at source module is for you, because it adds a whole bunch of extra hardware security in addition to the things that we are going to be shipping. Also, we thought about it from a developer enablement perspective, both from education, part of security is teaching folks how to write secure code, and also shipping security components. So one of the biggest ways that IoT is hacked today is that the username and password is just set to admin. And so all these cameras, we know about the Mirai bot that took down the internet, 2/3 of the internet, like 3 times. And that was because it was really hard to go in and change username password. And so we're going to be shipping a component that makes it super easy to put your Meadow in an AP mode. So connect to it locally and then set up your username password. We'll ship components that have like a web server that you can run on the device, and we'll already have that UI, UX. We'll even ship Xamarin components so that you can connect to it and do stuff like that. So we're really thinking about security from all angles. Absolutely. Also, this chip has a lot of really cool trusted platform computing features built in. So true random number generation. Hardware encryption, so accelerated encryption for like heavy duty 256K keys and whatnot. And as I mentioned, it has the ability to do secure boot. So this thing that like Microsoft touts about the Azure Sphere, this idea that you can, like prevent side loading and stuff, that's actually in the F7 chip. It's in a lot of microcontrollers, and we absolutely are going to take advantage of that. And so you can have that same level of application security there as well. And of course, the ESP32 comms can go over SSL, and we've really been thinking about that. So I know that's a lot of things, but and a long answer, but there's a lot of things that we've been thinking about that there.
Sweet. I've got some questions about Netduino. We've kind of retired Netduino, and so people are asking how powerful is Meadow compared to Netduino 3 Wi-Fi in particular?
Yeah, that's an interesting question. All right, so let me break it down. Netduino 3 Wi-Fi runs, the main chip was an STM32F4. The chip that's on the Meadow F7 is an STM32 F7 chip, and that's the main chip there. So that chip is actually twice as powerful and uses half as much electricity, which is really interesting, half as much power consumption. So right there, the main chip is twice as powerful. Also, we have the other chip on there, the ESP32 coprocessor, which we offload all of the processing of network to, right? So that actually not only is the chip a lot more powerful on here, but then we've also offloaded a lot of the heavy duty lifting around network, right? So that you can still do the real-time stuff that you need to on the main chip, responding to events and driving hardware and whatnot. So I would say also, I forgot about this. So this has 32 megabytes of RAM and 32 megabytes of flash. I think the Netduino Wi-Fi was in like the order of 2 megabytes or something. Wow. So there's like, magnitude times 2 in terms of like memory available and non-volatile storage. So a lot more powerful. It also has a battery charger, which is really cool because you can hook this up to solar with just like 2 wires and done. You don't have to think about that.
Yeah, that's awesome. That actually answers one of the other questions, because somebody was asking, how do you squeeze so much stuff in such little memory? So the power of Meadow, right?
So that's actually an interesting question. So how do we squeeze so much stuff into so little memory? Big ups to the Xamarin team. So a couple of things here. One, we're using a micro RTOS. And as I mentioned, micro RTOSs are measured in kilobytes. So NUDX, I think, is right now it's under 256K. It fits in a 256K memory block. I think it's 200K. So that's very small. And Xamarin did a lot of good work around making the mono runtime smaller. Right now, I think our mono runtime is about 1.5 megabytes, which is incredibly tiny. And as we turn on linking, what will happen is that or tree shaking as it's called, what happens is that most of that runtime isn't actually used. Most of the base class library isn't used. And so we actually strip out all those unused functions and whatnot. In that linking, again, hats off to the Xamarin engineers who really made that work very well because of Xamarin iOS and Xamarin Android. So we are standing on the shoulders of giants. We really are. If it weren't for, Xamarin, there would be no Meadow or no Wilderness Labs, and if it weren't for Microsoft and .Net, there'd be no Xamarin. So and if there weren't for Java, there'd be no .Net. So we, like all scientific and technological process, we are standing on the shoulders of giants.
Awesome. So another question from one of our attendees: will we have the Meadow OS for more microcontrollers like Nordic or Expressive?
Yeah, absolutely. So we do plan to expand Meadow OS to other microcontrollers. We'll be very selective about what we do. It's really about use cases. So we want to know, what are your use cases, and then let's go solve those. So one of the biggest ones is that we would like to do an Expressive based, an ESP32. Based one, and actually we've had early access to their next gen chips, which allow them the memory and stuff that we need in order to run our runtime. And so an ESP32 based board is definitely on the roadmap, possibly next year. And that, something like that is something that you could embed at scale for like $10. Mm-hmm. And so that's something that you could put in everywhere, like this is a pretty high powered board. And, when you go to embed this at scale, it probably costs somewhere around $30, right? But we do definitely want to target our chips and get that down. And also we plan on, we'd love to rev an H7 version of this. So that would be H7, for those who don't know, that's like the next level up in the ARM Cortex series, and that is like the top end microcontroller basically that's out there, and that would be for like solutions that have heavy graphics loads. So that has very good graphics I/O, and it could handle high resolution camera input and output and things like that. So we think that we are going to target both up and down the stack, and really the more successful that we are with what we're doing now, then the more things that we can do in the future.
Yeah, that actually kind of leads into this other question, which was from an attendee as well. Are there any plans for field-ready types of boards that could be deployed in hostile environments, like outdoors, or in factories?
Yeah, absolutely. So first of all, that's the point of the SMT module is for industrial environments, and Meadow is going into space soon. So Meadow is actually going into satellites, and one of the team members actually works at a company down in Austin, and they make a satellite ground station, and Meadow's going into the reference satellite design. So it turns out for low Earth orbit, actually what we have right here is perfect. You put two side by side, and then we can use the watchdog to do failover and stuff. So like stuff like that's you can actually run on the existing hardware. Now for really intense industrial grade stuff, we absolutely plan to ship boards that have high and low temperature, temperature extreme and vibration capabilities and whatnot. And it's funny, we were looking yesterday at a microchip F7. The chip itself costs $2,500, but it's like it's ultra hardened, it's radiation hardened, and so Meadow can actually run on that pretty easily. So if you do have use cases like that, reach out to us. To email us at sales@wildernesslabs.co or hello@wildernesslabs.co, and we'll talk, because we also do custom engineering Meadows for folks. In fact, the SMT module started out as a custom engineering project for a gentleman in the UK who's doing smart meters and needed a particular form factor. So absolutely, we absolutely do plan to do industrial modules. Yeah.
Can you give us some examples of some things you've already built and that's run on batteries or solar? Do you have any projects you can share?
I don't think there's anything that is up on GitHub yet. Aperium runs on solar, and we do have a number of battery run projects that are kind of floating around the lab. So it's totally, absolutely possible. And when we ship our power APIs, it's going to get even a lot easier because you'll be able to put the board to sleep for days or weeks or months at a time and really be able to conserve energy. Awesome. And so I'm looking forward to those, and I'm really looking forward to showing you what we can do there on like an ultra low power scale.
Sweet. So I think Fireside Chat probably ends at 4. I don't recall the schedule, but I think it ends at 4. So I do have one question for you that's, I think, really relevant with today, given the pandemic. How does that impact the IoT industry? What does that mean for developers? How important do developers play in this with their role in this situation?
Yeah, that is a great question. I think there's a couple of parts to that. One is sort of the tactical side of it, and one is the strategic side of it. And let me address them separately. So from a tactical standpoint, one of the things that we're seeing right now is that developers and developer engineers are so important, and you have so much agency to help. That's the thing that has been really, really great about this is that if you look around, there's the Arduino, there's several Arduino open source ventilator projects and things like that, and like for engineer developers, this is a great time to shine because there's opportunities to really help, and there's like, and the other part of that is that we're at this changeover in epochs in the revolution of humanity's computing progress, right? So, and this has happened every 10 years for the last 30, 40 years, and there's a ton of opportunities anytime that there is that changeover. And so from a strategic perspective, there's a couple things to talk about there. One is that whenever this happens, companies look for new technologies to help them transition into these epochs and become competitive in places that they haven't, or seeing their competitors be competitive in places that they hadn't thought about before. And so we're in a time of rapid acceleration of development. Think of like the early days of mobile. Think about there was a gold rush in mobile, and that there was like this new way to build apps and this new way to consume apps. And there was a tremendous opportunity for developers and companies to play there. And so as we change into this new epoch, the next 3-5 years are going to be gold rush years, so developers that can do this type of thing are going to be in incredibly high demand, and they already are, as I mentioned in the keynote. So there's a lot of, this pandemic has been really a gut punch, right? And one of the things that we've seen in tech, and we've seen it elsewhere, is a lot of layoffs and whatnot. And so the thing about layoffs is that being laid off is a great time to upskill. It's a great time to learn new things and see what people are. That there's always a new set of demands for skills out there. So from a strategic perspective, it's a great time to learn hardware. And I'm not gonna like whether that's Meadow or that's whatever. You should be learning hardware. Period. If you want to continue to be competitive in the job market for the next 10 years, it's a good time to learn IoT. So like I said, from the strategic perspective, we have agency. We can help. We can do things that can help folks and make reduce pain and make things a little bit better. And from a strategic perspective, it's time to upskill and it's time to learn these things, because this is the time. This is also in these epochs is the time to. It's the time in which companies look to new technologies that can reduce their time to market and reduce their cost to do things. This is a time in which people are looking to reduce costs and still have to do the things that they want to do. And so it is absolutely a good time to be building hardware.
Yeah.
And
totally
COVID, man, I know it sucks, but we'll get through it. We're like curves flatten. We'll get through it. We're almost done. Till next year.
Well, this is going to probably be the last question to wrap this up, really. I know everybody's been on for all day, super excited, and thank you guys for staying on. This is our very first DevCamp. The last question here is, when is the next one?
I don't know. Maybe the next one we'll be able to do in person, and live stream. This was a lot of fun,
Yeah.
I don't know. I definitely want to do. I want to do another one. And even if another DevCamp is a year or 6 months away or whatever, I think I think this format has been really good, and I think that we can do this, and we can start to do pieces of this. Like this live stream thing. I've got a lot of ideas around doing shows like this and stuff, and getting folks engaged. And I know we're going to publish all these videos so you can come back and watch them. And we've been working on other videos as well. Like, today we published the through-hole soldering video, and I'm working on one for surface mount, so you can do your own PCBs. And so yeah, even if DevCamp doesn't happen for another year, whenever it happens, don't worry. We're going to put out a lot more content. The velocity on content right now is incredibly high.
Yeah, awesome. I guess to wrap it up for reals this time, for folks who want to just keep up to date, to learn more with what we're doing, what should they do to make sure that they're getting the latest information? Subscribe to our newsletter. I know we've got that.
Subscribe to the newsletter. Number one, join the Slack.
Follow us on Twitter if you haven't already. Twitter is at Wilderness Labs. It's just Wilderness Labs.
At Wilderness Labs.
Awesome. Well, that's it. Thank you, everybody, for joining us. And I think that's a wrap.
Woo! All right, folks. See you next time.